Hello, everyone. Good afternoon. Welcome to the Corda Developer Bootcamp. I'm Irina, and I'm presenting today with Peter.
Hello, everyone. This is Peter.
So we are developer evangelists at R3, and this is our second online webinar out of series of 4. And now we are going to build a first CorDapp. So the first webinar was Introduction to Corda, where we did the high overview of Corda components and Corda network architecture. A lot of our material you can find on docs.corda.net and training.corda.net. So as well as the links will be provided below the video. So let's do a quick recap of our first webinar, what we have learned. So just to remind you that Corda is permission network where parties communicate on need-to-know basis. So Corda doesn't utilize Gossip protocol, which broadcasts everything throughout the whole network. It's useful to think of Corda network as fully connected graph, where all nodes on the graph are actual Corda nodes. Each node represents any individual or organization, meaning any party. And each runs on the Corda software, which is an instance of Corda and one or more Corda applications, known as CorDapps. This is what we are going to build today. Also, all of the nodes in the network have the potential to communicate with other nodes. So as long as you can see another node, you can message to it. You always should know a destination of a message and send it directly. This is what we need for today. And in Corda, there is no central store of data. Instead, each node maintains its own database of those facts that is aware of. The facts that a node knows about are those that the node is involved with. So there is no central node to store everything. This is misconception with Corda that people often think. So Corda network has a network address book and a node. Corda node runs within a Java virtual machine. This is a mechanism for nodes to discover Corda virtual machine. There is a mechanism for nodes to discover each other, which is network map service, which is a list of all nodes of a network. And we also have a node tree that prevents double spend. So let's also remind ourselves that CorDapp consists of a state, contract, and flow. And so today we are going to build a token CorDapp that will be doing only one thing, issuing a token. And for this, we need to implement 3 Java files. So state is a piece of piece of data or shared fact. So because typical use case of Corda is to allow different organizations to message each other and transact with each other, this is essentially they're transacting a shared fact between each other. This piece of data doesn't exist in central repository, but instead it exists in all nodes that participates in this event. Also, there is a contract that is a list of business rules that parties agreed upon installing CorDapp, and this contract runs against every transaction. And flow is just executes the business logic. You can think of a flow as a main function in Java, as a starting point, but you can have many of them. And so let's start with the coding. So here we have token state, And as I mentioned, states define shared facts on the ledger, and our state is a token state. And this token state will define the token. And again, shared fact is a piece of data that doesn't exist in central repository. And it's also, these states are immutable and cannot be changed. So you should think of a token state as a database table where properties of a class are columns in the table. And each instance of the class, one instance of the class is a table's row. So since I mentioned that parties, anyone on the Corda network can communicate with each other, this will be our first property of a class. Which will be So this will be the issuer who will issue the token, and then there will be another party which is owner of the token, which I will. And also, it's good to know how many tokens are issued. So I let this. And we also need to put a list of all participants in these transactions who will know about this state. So we will send any. They will be aware of any updates or deletion of this token. So we have some properties for our state, but how would Corda know that our state is actual state? How would we recognize on the Corda that this is a state? For this, it needs to implement an interface contract state. And then you see here there is like a red squiggly line around token state, which means it has to implement an implemented method. And this unimplemented method means that it needs to know about participants, that it has to the participants in this transaction. So for us, this is participants, has to return participants. So this is the way that Corda recognizes this class as a state. And it makes sense to inform issuer and owner here, so that's why I will add them as a participants. And they will be informed on any modification of this state. So as long as you inherit from a contract state and override get participants, Corda will know that token state is a state. So from as I mentioned that because Corda is a permission network and it knows about transactions on need-to-know basis. That's why we need to have this participants method. So also we need a way to create an instance for this class. And for this, we'll have a constructor. Section, implement constructors. So I will just send that. So let's populate participants from our party and issuer. So will be new. Then and let's add our issuer. And owner. So we also need to wait to retrieve properties of previous states. Since this every state is immutable, we only implement getters for each of our property. Again, we'll do source action getters. So if you have a contract, you might want to attach it to a state. I remind again, contract is a set of rules that we run against our state to make sure that it passes the business logic. Contract gives us a set of rules, and we can we can only change the state according to those rules. So, for example, if we are allowed to change the owner, or if we are allowed to change the issuer, and this contract is in order to tie the state to a particular contract, we annotate it with belong to a contract, which is just here. But every time the state is used or changed, a bytecode of the contract class will be attached to it. And the nodes will run this contract against the proposed change on the transaction to make sure all is valid. So the contract will follow a state through its life cycle, and you are sure that anyone who runs a transaction on the state have to follow a business rule that has been implemented in the contract. So we will uncomment this annotation later when we implement token contract. Now it's a little bit preemptive. So let's summarize what we've done so far. We need our state to be inherited from contract state. We need to set up properties for the state. So it's issuer, which is a party, which any entity of the network. It's owner and amount. And we also need to implement the participants, get participants who will be notified about any modification of this transaction. So I cannot run these tests on the state at the moment because I need the contract has to be implemented first. So I will pass to Peter, to my colleague, and he will do the contracts. Peter?
Sure. Hello, everyone. Thanks, Arina. So basically, on this slide, you're gonna see that it is exactly what Arina just did. It's a token state Java, and it has three property: party issuer, party owner, and it's a integer type amount. And speaking of which, we're gonna do a quick fix. Here, it should be int. It's okay. So it's integer, and then lastly it's an int, and then we are all good to go. And also, as Arina is mentioning, line 14 belongs to token contract. It's currently commented because you see, if we uncommented, it's gonna give us error message saying that it's not implemented yet. That's right. That's why I'm going to teach all of you how to implement the token contract, which is this file. Sure. But before we go that, let's talk about what is contract. So Corda contract, in the Corda system, the ledger or the blockchain, the DLT, like the ledger update is done through the transaction inflow. and the contract verifies the validity of a transaction. So what that does mean is, hold on, there's a typo here, but when we're doing a transaction, we have the input, which is the existing state, and then we do some calculations, which in the later is we do the calculation in the flow, and then we will have a desired output state, and that output state is the output of the transaction, and then we encapsulate them into transaction. You're gonna see that like the transaction carries the input, which is the existing state, and then the output, which is the desired state, and then that transaction needs to go through a set of contract rules. Rule number 1 check, rule number 2 check, rule number 3 check, and when all the rules checklists are done, the ledger updated, and then it's recording the changes. But what if one of them failed? For example, rule number 3, it says you're gonna do you cannot send any transaction with amount more than $100 because you don't have like enough money, or like your wife just doesn't allow you to. Then your database or the ledger will not get updated. It will get rejected. So bring back to what we are going to do today. In our token CorDapp, we're gonna do a simple issuance transaction. We're gonna have 0 input because we are making an issuance. And we're gonna have a command which indicates the intent of the transaction, which is the issue. And we're gonna have output. We just, we are the issuer, we can create the output out of nowhere. And the token, the output is actually the token state that Irina just showed you guys. So this is the transaction what we're gonna build. And remember, ledger updated is done through transactions. And what's important for the transaction is all the checklists, the contract rules. And here are the contract rules that we need to follow. So we're gonna implement all of this in the token contract.java, and then there will be 7 rules. The first one is no input because we are doing an issuance. And the second is, since we are only doing a simple transaction, there has to be only one output. In a real production program, you can do as many as output you want. But for the sake of simplicity, we're just gonna do one output. And third one is one command, output the token state. We're gonna go into deeper for this one in the code while I'm talking about this. So yeah, let's go. Let's switch to the online IDE. So here we are back with online IDE. Let's all navigate to token contract. So actually, before we do that, I saw a question that someone is asking, like, oh, what's this page? So if it's in our the emails, the pre-set up emails, but if like you haven't seen those before, you can just go to ide.corda.net, ide.corda.net. So it actually gonna load you up with the IDE, like a unique instance just for you. So that's like the page we are working at. Sure. Okay, let's get started. First thing first, the type, the class type. So we're gonna do implement contract because every contract code in Corda implements a contract, and we're gonna do the importations. We don't have the contract here yet. Import net Corda.core contracts, and that will give us net Corda core. Oh, sorry, contracts, not contract. We are good to go there, and then you see here it says we need to implement some override methods, and then we can click on a quick fix, add an implement method. So this is the method that we're gonna have our code in, which is a verified, and then we're gonna talk about the commands later. So everybody is following. We have questions? No. Cool. So let's change the parameter to transaction just for easy implementation. We're gonna implement the 7 rules that we talk about. The first one is like no input, and then the second one is no output. And let's do that first. No input. So when we have a transaction coming into the contract, how we know like what this contract is should verify? So that's actually we need to have we need to know what command is coming along with the transaction. That's where we implement the command with parties. So this is type command with parties, and we want to specifically say that they are token contract commands. Because for our contract file, we only want verifies the transaction that is related to our commands, which is here, which is the issue commands. And then we can just give them a name equals, and then here we're gonna use domain specific language, which called require single command. So this is a method that we implemented, by R3. So we're gonna all do the importation here. Import. This method will just make the contract writing much easier. Net.Corda core contract DSL. Haha, here. And then we're gonna do require single command. And then this is the slide. This is the method that we are using here. And then we're gonna get the transaction. We're gonna get all the comments, and then we're gonna specifically implement say that we want token contract dot commands dot class. So this is like the Java way to do this. With Column, we have sample codes to show that how you can do this with Column. And what's the next thing? So we want to check their no input. So how are we gonna do that? We're gonna actually bring the entire input list out of the transaction. That is list, and then we want to specify the type, which is the contract state, because we don't want anything else. State. So I think we need an importation on the list. Import contract state. And then input. Close transaction dot get input. Input space. So this will return a list of contract state, and again we need an imported contract state. Okay. So here let me just quickly just do that. That's gonna fix it. And this is because class is import. I actually think in the GitHub repo, all of the importation is all done with our latest updates. So we actually have everything ready for you. So you don't need to do all of this importation like I am. You can just straight to the code. So here we go. We have our needed variables. Now let's actually do the contract. So the logic is very simple. We want to check that if the command that we are getting is the instance of token contract command the issue, and then we're gonna like take care the cases when the command value is not of issue. So the logic is, you see, right now we have a class issue implements commands. We can also have, for example, I mean, just copy paste. We can also have transfer, and we can also have, we can also have settle. Yeah, but for the simplicity of the bootcamp, we are not going to do so. So once we have those commands, we're gonna have here is like else if it is a command instance of transfer, then we can take care of all the contract checklist for the command of transfer, and then we can do another else if for the command of settle. So, but for the simplicity of today's bootcamp, we're just gonna do a simple issue, and then there's only one command, and then we're gonna do another domain-specific language DSL like this. That to make contract writing much easier is require that. Okay, let me do the importations. Static net.corda contracts DSL require that. Boom. With this DSL, you're gonna have a much easier life, to be honest. Require that. It's a method, and don't forget to close the method. And then within it, we're gonna do the require, which is the instance of the method, and then the lambda. Those are the actual rules that we're gonna implement here. We need to end this with a return no, and then it's gonna clear the arrow. And then here's actually we're gonna implement the rules here. Simple as that. Rule number one: no input. So how we do that? So we're gonna also take advantage of the DSL and then just say required using. So you see, take two arguments. The first argument is actually the rules that you want to implement. You can actually type the string inside here. So we can say transaction must have no input, exclamation mark. And then here is actually the booleans that we want to check. So input is empty. So remember we got the input from the transaction, get input, and then here we are. And then we are just simply saying that the input list that we get from the transaction should be an empty list. Otherwise, we're gonna see an error message saying that transaction must have no input. And we can quickly take a look of the second one output. We can also do that. One output. Again, require.using this, and then error message transaction must have only one output. So this is another thing. Is like it's good that to actually have the message, because if you run, like you do unit testing, or you actually deploy your application in a real environment, production mode, when someone try to send you a transaction that violate one of the rules, it's actually going to show in your log, so you know exactly what's going on. So it's not just like type it here. It actually has a greater purpose in the real environment. And for that case, for the output, let's create another variable. Basically, it's the same thing, contract state output equal tx dot get output. And what we're gonna do here is output dot size. It's a Java thing again. Size equal 1. Done. We are done with the second one. And then the third one, I think, is about. Okay, let me actually just copy paste all this. And so the one command is like we already take care here because we are required a single command. So we don't need to take care of that. And then the next one is the output is a token state. So here's how we're gonna do it. We know that we already have the list of contract state, and then now we need to check the actual type because we are doing an issuance of the token contract. That means we want specifically work with token state, and the output of that transaction we also want to limit it to the token state output. You know, again, like in the real environment, in real CorDapp, you can do whatever you want with your contract. But for this one, we want to say the output must be a token state. And require using, see, like, oh, do you guys see, like, it started to become handy. I don't need to type all this. Output must be a token state. And for that, we're gonna actually bring out token state output equals casted token state output dot get 0. And we're gonna check that output. Wait, hold on. No, we don't need it because we're gonna do this. That's for next step. Sorry. Dot instance of token state. Yeah, because I was thinking about the last rule. For that one, we need this because yeah, for the next 2 or 3, because we need to actually get the token state. Yeah, if we already cast them to a token state, then this contract wouldn't it's gonna successfully verify anyway. So yeah, so for this one, output is a token state. We are just getting the first. We are getting the first state of the list because we already know there's only one output in the entire list. And right now we are getting the output out of the output list, and then we're gonna check the output amount field is positive. So we're gonna do this, require dot using I can actually paste that. And this, we're gonna actually go into the token state. So output dot get amount, and then they must be 0. So this getter method is where Arena implemented in the token state. Remember, we implement the 3 getters, right? 3 getters. One is override. And the next one is the command must be issued. And for this one, we are using the command again. Require dot using and then we can check. Hold on. Issue is required. No. We already. Oh, sorry. We already covered this. this. Oh, oops. We are going to implement this one. The required sign issuer is a required signer, and then we're gonna use the commands. And we're gonna do command dot get signers. So this will actually get all the signers out of the transaction, and then we want to see whether it contains what. It contains the output dot get issuer, and then we want to check for their if their owning key is signing. And I think we also need check one more, because we also want the receiver, the owner, on the sync with us. So this is, sorry, change this to that, and then we want to make sure the owner is also with us, and this is done with command dot get signers dot contains output dot get owners dot get owning key. Yeah, I think now we are all good. Like, yeah, in the slide, those like one command is issue is you know, it's pre-tested here. So I think now we are all good with our contract, and it's just simple like that. Now let me just check if the token state is still complaining about it. No, it's not. We can actually test it if Irina's implementations and my implementations on the contract is working. Finger crossed. Okay, let's go to the test. So, you know, if we select the test, we select the bootcamp, we select the state test, we see we have 4 tests that is commented out. If we uncomment them all together, you can click the command slash. We can actually run them. We can run the entire test here. Run test. You see at the bottom, the test is running. Hold on, build fail. Is it? We can see the test result here. Click on the little bigger item, say test. Here. Run. Fail to build. Override. One test pass. Great. Hold on. Let's run test. Can we run all of them? Yeah. Okay. Our state test all passed, and now we move to contract test. We need to comment it out everything. Contract test here. So we can run this. A little bit more on the unit tests. You might wondering, oh, what are those tests? So you see, those tests are pre-implemented unit tests that's, you know, we want you guys to do, you know, test-driven development. So that means when you actually implement the contract, and then you're gonna see whether your code actually is working or not. You're gonna run those tests, and then those tests is specifically customized for each one of the contract. For example, the token contract requires 0 inputs in the transaction, and you know, if you run this, if it fails, like for example, that means like this line of code you implemented incorrectly. So those unit tests will help you, you know, basically debug your code. And we actually, you know, highly suggest it's a must-have when you do real real production CorDapp. So let's take a look on the test result. So click on the test. Whoa, that's beautiful. So we have all the tests passed. That means Irina's code works fine, and then my code works fine. So I guess now I'm actually switching back to Irina because she's gonna go over the flow session. So she's gonna code it out the flow session, and then I will continue after her to show you guys how you actually deploy your nodes and then run your network on this online IDE. Sure, take it away, Irina.
So yeah, so hello, I'm starting with a flow initiator. So just to remind you, flow reflects the business logic of your CorDapp. And since we're in the network, it usually communicates with the other nodes. And it usually just says when to communicate, what to communicate, and who to communicate with. So over here, we see that it's annotated with the initiating flow. And we also have a responder flow who will be annotated with initiated by. So this means that anytime this flow creates and sends transaction across the network, the counterpart node will automatically reply and respond with the responder flow. So you need the node to define initiating flow and define responder flow in the counterparty node. But it's not usually that you need to have initiating flow. Sometimes you might just want to start with a hello world flow, which just return hello world. And in this case, you don't need initiating flow. So also for startable RPC, this annotates the way that we started. So the way that this is how primarily a way of user who is not admin to interact and start the flow. So by extending the flow with the flow logic, Corda understand that this is implementation of a flow, and signed transaction is propagated as the return type of a call method. So you can think of your call method as a main function, your program entry point. And if you call your flow by RPC command, it interacts with the node. When the node gets request to instantiate this flow, it will create an object of this class and automatically jumps to a call method and execute the logic inside your call method. Your call method needs to be annotated with a suspendable, since this method has to be overridden from flow logic. And when you try to use your IDE auto-generate call method, it won't annotate with suspendable. So don't forget to edit manually then. And I need it since when you send anything over Corda network, this flow object is serialized, saved on disk locally. It's basically taken out of memory, out of JVM, packaged it, and saved it. So with the suspendable annotation, Corda realizes that everything inside this function is suspendable, and it will suspend it. So the purpose of this flow, like this business logic that we will implement, is to issue a token, and you need to gather like all criteria that are necessary to initiate the transaction. So let's assume for the simplicity that the caller of this flow, me, is a issuer of the tokens, and I will derive them in the call method. And we are going to define a node party who creates transaction proposal. And but I need to know the owner of this token and the number of tokens. So I put them as a class properties, and then I pass them in a class constructor. So this is we have here. So this is our call method. And this is, so we start with defining a notary. And the way Corda, so I will remind you what the notary is. So it's the way Corda prevents double spans is by having independent notaries in the network. Every transaction requires a signature from a notary to be valid. A notary does not actually see the content of states. It only sees a hash of each transaction and index of the fact being consumed, like state, and inputs of the transaction. So no any other data that comes from input or transaction are seen by a notary. So notary checks all those IDs against its record list. So it tries to answer the question, have that input been ever seen before? So did the party have spent tokens already or not? Whenever a transaction is coming in with the same input, the hash will match, meaning the notary have seen this input before, and it won't approve the transaction again. So it will completely eliminate chance of double spends on the Corda network. So here we use a service hub. A service hub is our like API to our node services. So you can get like things like network map hash, which is our address book, and which has a list of all like counterparties and notaries on the network. So you can get your database, which is like Vault, your node identities, and your node information. So here I'm grabbing the kind of address book and all the notaries that are in the network that are available, and I will get the first one. So this is actually ease of use to show in this example, but it's not the best practice. Like the best practice is you will be able to know which notary you're dealing with. So when you actually create your Corda network, you'll have options to get your notary by Corda 500. I think it's here. This function, and which is this name is unique on the network, and so. But here, let's do for simplicity this one, and also like here I will get I will get I will get like my identity here. So I'm using the same notary and I'm issuer, which is name. So let's start with the token and create the token state, which is a new token state. And so I have issuer, owner, and amount. And in order to build a transaction, remember in the contract, Peter implemented the checks that we need on the zero inputs because we're issuing some tokens, and one or more output, and at least one command. So let's create it from the list of commands that Peter implemented for us. So let's have a command data. So I'll have issue. So so we use so on the transaction builder is basically the kind of Java builder paradigm which instantiate a transaction. So we just need to tie it to a particular notary. So let's go. And let's add our notary. And let's put like all pieces that we created together and add it to a transaction. So we add second, so we, because we don't have inputs, we have on the outputs, let's add output state. Output state. And then this will be our token state. And so we add second optional parameter to specify the contract that we use for this state. This will be our token contract ID. And so now we add the command that we have. Data. And we also need to add a list of all participants who will be notified about updates on the state. But here we'll add list of here we everyone in the list that we add to this command will have to sign this transaction. And so let's add issuer. So it's us, our owner key. So we need to sign it, and the owner. So from the contract, we only enforce an issuer to sign a transaction, but we add owner as well. So what it means that that it's not enforced, and like our transaction is like flexible. So we just do it for the sake. And contract is just a checklist that we must we know for sure that we will be enforced. So we created a token state. We created a command, and we use a transaction builder to build up all the things in transaction together. So transaction builder is the way to propose a transaction. So didn't see our command data, so let's import command. So we check we also check that our command is valid based on the contracts when we do verify. So our contract will be called, and all the checks that Peter implemented will be checked, verified here. And so we initiate the flow, and we sign our transaction. So after we run the contract on our side, and we make sure that the contract all the checks pass, we have to sign it. And here we have also a collect signatures, which is a flow from our like library flow, and it just sends this transaction for approval for all parties. In this example, to owner, and the counterparties will run their contract, that checklist, and on this transaction to make sure it satisfies their conditions, and then they can have additional checks as well. And when they signed it, it will automatically send back to me. So later on the subflow, what we're doing here, so this is our finality flow. And finality flow runs after all signatures are received and sent. This transaction goes to a notary, which checks inputs for double spend, and notary will sign it, and then it sends back to me, initiator of the transaction, and all parties that have been involved. And we'll store it in our database ledger and send it. So every counterparties then will have the same copy. So you see what I see. And so yeah, here we send to the notary for double spends, and notary will send it back to us. So this is the initiator flow, but there is a responder flow as well. So let's have a look at the responder flow. And so when initiator calls collect signature, the owner sends a proposal to responder with the which is like annotated with a token issue initiated by, and with this class that we implemented. So as soon as responder flow is called, it runs a signed transaction flow. It forces which it forces me like to override. And so override this checks transaction, which is so we also can check add additional checks for our contract. So contract is a checklist with like global constraints. Everybody on the network who installed this CorDapp has agreed to have, but we also can able to add our own personal constraints here. For example, I, Irina, don't want to have a even amount. I don't want to sign them. So I will here, I will add, I will check if amount is even or not. And otherwise, so if I leave this check transaction blank, only contract constraints are enforced. So, and this is finality flow is pairing with the flow from initiator. And we'll receive finalized transaction after the notary signed it, and we'll write it to the ledger here. So now let's move to the flow test. So on our flow tests, what we have is our test that we need to uncomment. So for to test a flow, we need to set up like mock network and start two nodes, as Peter mentioned it, and then we initiate the flow, and here we waiting on the result of our flow, which is signed transaction. And then we do assertions on that signed transaction. So let's run the test.
Just click proceed, Alina.
Okay.
And then I think you can run the test again.
Okay. Run. They're running, right?
Hold on. Let me see. Oh, I think you need to refresh, like of the browser, like do a total refresh.
Okay. To pick up your changes.
Yeah.
Okay.
Yeah, to pick up my changes. And actually right now I'm running the test. And when I finish running the test, you can show you can show the students again. Yeah, okay, it's done on my side. Try running on your side.
Running.
Yes, you already have 2 paths, 3 paths, you see?
4 paths. Yo! I see. Yeah. Okay. Yeah. So yeah, we passed the tests. Yeah. And so now we just build our simple CorDapp to issue token, and we just like issued it. And yeah, shall we Peter, shall you show how to deploy the node?
Sure, I can take over.
Mhm.
Hello, everyone. It's Peter again. So we are back with IDE, and then Elena implement the token state, and then I implement the token contract, and then she implements the issue flow. She also go over the responder, which we are not necessarily doing anything, but that's it. Like when we're building a CorDapp, that's everything. That's everything we need. You just need a state, contract, and flow. And now let me show you guys how you actually run these applications in this instance. It's gonna be like sort of exactly the same when you running them on the local machine. Let me do a refresh. Okay, cool. We have it. Let me just open the code there. So we can actually do a ls first. So we're gonna see like what are the files in the directory, because I think we also see some questions in the chat that people are curious what are the structures of the folder. So everything we're gonna run a mock network. Everything that's in the network is written in the build.gradle. So you can control how many nodes you are running for your mock network. We can actually, yeah, let's take a look. So this is the build Gradle. And then if you scroll to the bottom, it has a task, deploy nodes. So we're gonna deploy a mock network that requires 4 nodes. So one is a node tree, because node tree is like the source of truth of your network. Party A, party B, and party C. So we are going to do a single issuance between party A and party B. And then what we want to demonstrate is you're gonna see that state or that fact is only shared between party B and party A, because all the transaction is on peer-to-peer. So we also gonna see that party C is not getting anything. So this is what we try to get out of the demonstration. So that's the build Gradle file. And then the Gradle is basically the running, like the engine of running the project. The Gradle W is a folder, is including a Gradle wrapper. So that's actually, we have all the Corda implemented Gradle plugins is all in that folder. README, logs, libraries, and all of our code is in the source. And also you can see, aha, here, solutions. That means if you didn't get a chance to actually follow our code, you can actually look into the solutions, because all the codes, all the solutions of how you actually implement token state, token contract, and token flow are in the solutions.md. Sure. Enough talking. Let me show you guys how to deploy the nodes and actually run the mock network. Gradle W, clean deploy nodes. So this task is going to compile all the code we wrote and then make them a jar. And then the Corda Gradle plugin is going to generate the folders, the directories that we need to run the mock network. And then we just all hit enter. It's generating. It takes less than a minute. Cool. 24 seconds. So after we all done with this, so for any people who are using the online IDE, we're gonna like follow me with Command Shift P. That's actually gonna bring out like the control panel of your online IDE. You know, with a Mac OS user, it's Command Shift P. And then you're gonna see we have a just type run. You're gonna see Corda run nodes. So for any people who's using the online IDE, click on the Corda run nodes. And for anyone who's actually following the bootcamp locally, you will need to go to /build/nodes, and then you're gonna run this like run node, and you're gonna hit enter. Virtually, they are doing the same thing. It's just on this online IDE. You see, we don't have the permission to open terminals simultaneously. We have to do it from the IDE. It's like the IDE owns this terminal. We don't own this terminal. So let's all do this. Run nodes, Corda run nodes. Click on it, and then you're gonna see from here, the top right of the terminal, it's gonna open up the node tree, party A, party B, and party C. You're gonna see them starting one by one. And then again, like if you are following along in the terminal, I can actually quickly show you, using a different CorDapp. You see just that /build/node/run nodes. So this is gonna do exactly the same. And after we start the instance, we're gonna see party A starts up, party B starts up, party C starts up. And also you can see there's always a joke. Every terminal is a random different joke. When I discovered my toaster wasn't waterproof, I was shocked. Yeah, right. Sure, so okay. Let's see how we can run this. So once we are in the node shell, we can do this. We can do flow list. It's gonna actually tell you what are the method that we can run. So it's gonna actually list out the flows that we had implemented in this CorDapp. So don't worry about the authorize, deauthorize, and initiate. Like every single CorDapp will have that three. And for this one, we have the token issue flow initiator, and then the art transfer flow initiator. Like that's in the example folder. Like we never really cover it, but during our old eight hours bootcamp, we sometimes go over the examples. Let's actually run the flow. Flow start. And then we can just token issue flow initiator. So, after we typed the flow name, someone might wonder, okay, then what's the parameter? Like, when we have a larger project, we're gonna have like 50 flows. How are we gonna remember all the parameters? The answer is you don't need to. You just type flow start token issue flow initiator, and if you hit enter, it's actually gonna tell you no magic constructor find. We need to implement the owner and the amount. So let's also do that. Owner. We are in party A, and we want to issue a token to party B. And amount 50 tokens. The moment of truth, enter. Starting, collecting signatures. Done. So the reason it takes that long because we are sending the very first transaction ever between party A and party B. So it means like you need to get the network, the transaction channel, the messaging channel warmed up. So if now we send another transaction to party B, it's going to be much quicker. So it's going to happen to all of your nodes. I mean, like when you first send a very first transaction between nodes, it needs time to warm up the channel. Great. So let's go to party B and see if we have successfully sent a state or we have bit over time. So in party B, there are two ways to verify the transaction coming in, and then is the data successfully recorded. The first way is we can just do a query. So we can all go to the README and then scroll to the bottom. You see this. Read vault query contract state type bootcamp state. So we're gonna copy. We're gonna paste here. Run. Aha, we have it. So that means this is the state that we get stored in our database. What is the state? Bootcamp token state. That's right. Who's the issuer? Party A. Who's the owner? Party B. What's the amount? 50. What's the contract that we just verified? Bootcamp token contract. The notary, which is a notary location in London, and then and then this is the other like useful information is like the transaction hash, because if Corda use UTXO model, that means if you want to trace back to the chain, you need to have the previous transaction hash to tell you like basically like what is the previous transaction, and then this is like the current transaction. No, it's the same. You're gonna need these hashes for tracing back. Okay, so let me show you guys the second way. The second way is actually look into the transaction database. You can simply do a run. It's gonna bring up all the runnable comments in the node, and then this one, internal verified transaction snapshot. So it's gonna bring you the snapshot of your current, like your existing all of your existing transactions. We're gonna hit run, and then we're gonna see something different. We are seeing the transaction database, because again, like remember this is the transaction hash we just saw that's in our database for the output for the state, and then now we are seeing it because we are looking at the transaction. And then for this we can verify a little bit more stuff. Is the input is empty because our transaction has 0 input, and then our contract, that means our contract is working properly too. It give a pass. And then output is this data, and then the comments is bootcamp token contract comment issue. Signers, we have to like we are not gonna see it like reading the public keys, but this is correct. Otherwise, it's gonna fail the contract. So these are the two ways to check that whether party B has the state or not. And let's actually go to party C and then do exactly the same thing to see if party C accidentally got anything. Hopefully not. We are at party C, and we want to check the state database, and we got nothing. And if we run the internal snapshot again, run internal transaction snapshot, and we got nothing. That's expected. And now let's go back to party A. We're also gonna do the same thing, because now party A should have the state because he's the issuer. And according to our rules, the issuer should have the state. Aha, here it is. Issuer party A, party B. And then by looking at the transaction hash, it's the same one as the one that's on party B. So now we just successfully demonstrate a peer-to-peer messaging applications. Just simply send a state between nodes. And we just verified it works properly, securely, and then privately. That means that's the beauty of blockchain, is all the communication is between peer-to-peer. I see a question that's asking about, what about notary? Okay, good point. So during our Corda intro, we talk about which is the previous recording of the session of the series, the very first episode of the series. We talk about notary. So what is notary exactly? Like if we try to do a flow on notary, will it work? The answer is no, because notary doesn't have the concept, doesn't know that concept of CorDapp. So the notary doesn't need what is a CorDapp. So that means if we run the commands that we run to check for the database, it's not going to have anything, because it's not storing, or it's not reading anything. So the notary has nothing to do with the CorDapp. The notary is only mechanism that verified has the input been double spent. Yeah. Does that answer your question? I hope that answered your question. Sure. Cool. So that's it for today for the coding part. And lastly, I want to come back with you know, a little bit logistic. So if you are ready, if you love our sessions, if you're ready for the next workshop, we have the next one on accounts workshop on June 18th, and then we have a token SDK workshop on June 25th, and we're gonna run them 4 times every day. So 2 p.m. in London, New York, and then Mumbai time zone, and then 10 a.m. in Hong Kong time zone. And for the London, New York, Mumbai, we're gonna deliver them in English, and for the one in the APAC area, we're gonna deliver them in Mandarin. And we're gonna close this with some Corda reference. So free training side. So if you think we are not good enough, you can actually go to the training site yourself. You can learn from how to build a CorDapp. You can learn the key concept about Corda and then do a recap and everything. Just go to training.corda.net. We have a lot of useful information there. We have you know, step-by-step how to set up your environment and how to actually like detailed explanation on each file of the directory. That's the training. It's a big shout out to the training Corda.net. And second one is join our community. Currently, I think we are looking at 9,000 people in our Corda ledger, in our Slack. It is again, you need to get the invitation. I mean, again, it's automatic invitation. Just go to slack.corda.net. You can join our community. And for developers out there, come to if you run into any issues during the development, go to docs.corda.net. We have our very thorough documentation, both in Kotlin and Java. You know, on the top you can select whether you want to read Corda Kotlin docs or Java docs. They're very you know, we try to make our the API or API oracles the same just as Java oracles. It's very simple to read. GitHub repo, GitHub/Corda, and so is this bootcamp CorDapp. So if you go to you know, github.com/Corda and then /bootcamp-CorDapp, you can get a clone of the exact copy of what we just done here, and then you can just, you know, run it like no matter how many times you want. And then lastly, if you want to get, you know, personal contact with us, you can send an email to devrel@r3.com. And then lastly, just big shout out to our marketing team, Twitter @Corda Blockchain, @Inside R3, and the hashtag Corda and R3. Okay, thanks everyone. This is Peter and Irina.
Thank you.
Thank you, everyone.
Thank you. Bye-bye.
Bye.